who here thinks that's a forest? Hands up if you can. All right, got a couple. Yeah, where I'm from, I wouldn't call that a forest either. The point is, it's a subjective thing. It depends where you are in the world, it depends who you ask. But sometimes we need to have a definition of what is a forest and what's not, so that we can measure where forests exist and where they might regenerate in the future. So to do that, we have a definition called forest cover. And in Australia, that's defined as 0.2 hectares of land with trees greater than 2 meters in height, contributing to a canopy cover of at least 20%. So how do we measure it? Well, the traditional approach is going out to a site, laying out some transects, walking along with a stick, and literally just measuring each tree manually. That's fine, like it's industry standard, has been for a long time, but there's several limitations. It takes a long time. It's subject to bias and error, and it's really hard to repeat the same measurement twice. It's also quite limited in how much you're actually getting from that site. So one transect is really only showing you a 1D representation of that site. So at this site here, we've got 3 transects in red, and that's giving us a canopy cover of 19%, so very close. But if we rotate those transects and look at all the possible variations, we actually end up with a range between 10% and 26%. So there's a lot there. How do we improve this? Drones. We can easily fly a drone, create a canopy height model, and measure the height of every single tree on that site. So we're getting 100% coverage. We can then go back year on year, measure the same site, the same settings, and have a comparable data set that we can then track forest cover over time. LiDAR would be nice, but we don't always have the budget for LiDAR, and sometimes you don't actually need it. With these open canopy forests, we've got enough coverage of the ground that photogrammetry actually works pretty well. So that's what we've been using. And how does FOSS4G come into this? Well, we're using it at pretty much every stage of our workflow. So the images we collect with the drone, we're processing with OpenDroneMap into high-resolution orthomosaics and point clouds. But rather than using the DTMs and DSMs from OpenDroneMap, we're actually using the point cloud itself, because there's a few things we want to clean up before we actually estimate tree heights. So firstly, we want to get rid of noise, so quite often have outliers and low noise in photogrammetry, and so we can develop workflows to get rid of that. Dead trees, quite often dead trees can lead to overestimating heights if there's a smaller tree growing around its base. So we've developed another workflow that identifies those sort of bare branches that stick up and gets rid of them. And all of that's done with PDAL, the point data abstraction library. And then once that's done, the ground classification, so separate the ground from the vegetation, then we can estimate tree heights. One last thing, we want to separate trees, because if you have a big tree and a small tree, you don't want to count that entire canopy. One of the trees might be below 2 meters, and sometimes it's quite hard to do. But we've had pretty good success in actually segmenting the point cloud. We're doing that in Cloud Compare. And by doing that, we've improved the overall accuracy of the canopy cover. So that's point cloud all classified and cleaned, and then we just generate our final outputs with GDAL and visualize in QGIS. That's me.